We have two lines given in this question and they're given by vector equations. I just want to remind you what these vector equations represent. So this is the line, and let's say we've got an origin. Then the first vector is a position vector, and it gets us from the origin onto the line somewhere. Then the second vector is a direction vector, and it takes us along the line. And the fact that we've got lambda decides how far along the line we go. So that means we can get anywhere along the line, and the final place will be the position vector from the origin to that point. The second one will then be some sort of other line, and again we'll get onto the line somehow, and then we'll go in some direction. Of course, you go in the other direction as well. And we're interested in where they intersect, and where they intersect is where the R vectors are the same, exactly the same, and so essentially we can set them equal to one another. And what we can do is set the x parts equal to one another. So 8 minus 2 lambda is equal to minus 6 minus 3 lambda. We can set the y parts equal. And we can set the z parts equal. Now we have three simultaneous equations with two unknowns. What we have to do is solve two of this pair of simultaneous equations and just check that the third works. You can always solve two of them to get an answer, but it might just be that then it doesn't work in the third one, and that would mean that they don't intersect. But because we're asked to show that they do intersect, essentially we're going to solve two of them and then just check the third one, check that the solution is consistent with the third equation. So you could decide which ones you'd solve. Because we've got a plus mu and a minus mu, actually this seems a good shout. Rather than multiplying the equations, we can just simply add the second two together. I'm going to call the first equation 1. Then we've got 2 and 3, and I'm going to add 2 and 3 together. So that's going to give me minus 13 plus 8 lambda equals 19, and these cancel. That means that 8 lambda, if I add 13 to both sides, is 32, and lambda is equal to 4. Okay, sub back in as we normally do with simultaneous equations. And you can sub it into either 2 or 3, not into 1, into the 2 that we've actually solved. And it's probably going to be easiest to solve it into 2 because I've already got mu by itself rather than having minus mu and having to deal with it. So I'm going to sub back into 2. Then I'll get minus 11 plus 20, 5 times 4 equals 11 plus mu. So 9, because that's what minus 11 plus 20 is. 9 minus 11 equals mu, and mu is equal to minus 2. So check. That solution is consistent with equation 1. The left-hand side is 8 minus 2 times 4, which is 0. Right-hand side is minus 6 minus 3 times minus 2, which is also 0. So it works, it is consistent. L1 and L2 intersect. For B, we're just asked to find the point of intersection of L1 and L2, and all we need to do is actually substitute in either the mu or the lambda. So I'm going to substitute it. I'd substitute it into the first one. If you want to be extra careful, you could just substitute it into both. But we can be pretty sure our solution is okay, especially because we've got 0 there. So R is going to equal -8 positive 8 -11 -2 plus, and then remember we've shown that lambda's 4. So I can just multiply them through. -8, 20 and 12. That's going to be 0. Actually, we've got that a minute ago. 9, 10. So point of intersection. Remember, that's technically this is a vector going from the origin to the point. The point of intersection should be written as coordinates. 0, 9, and 10.